IPMAT 2024 short answer question. The number of pairs x, y of integers satisfying the inequality mod x minus 5 plus mod y minus 5 less than or equal to 6 is what? Very interesting question. Multiple ways in which we can approach this problem. Let's see a couple of them. First things first, mod x minus 5 and mod y minus 5. Can I substitute them with something easier? If I assume that x minus 5 is a and y minus 5 is b, right? So mod x minus 5 can be written as mod a plus mod y minus 5 simply becomes mod b less than or equal to 6. Now, how does this help? If I can find values of a and b, for every value of a, there is only going to be one corresponding value of x, right? A plus 5 is x. So whether I say x minus 5 or I say a, I just have to find the number of such numbers. So I can eliminate the minus 5 thingy in my calculation. So let's keep it mod a plus mod b less than or equal to 6. Okay. So now what does the mod do? It converts the number inside to a positive integer, positive number, or rather I should say a non-negative number, because 0 can be there. So minus 4, mod of minus 4 is 4, and mod of plus 4 is also 4, and mod of 0 is 0. So adding two non-negative numbers in such a way that the sum is less than or equal to 6. So I know that to add two positive numbers such that the sum is less than or equal to 6, there are only few possibilities. Now, a could be the number 6, 5, 4, 3, 2, 1 or 0. So in this case, what are my possible values of b? When a is 6, the only possible value for b will be 0 because no other value of b will make it less than or equal to 6. For 5, I can use 0 or 1. 5 plus 0 is 5, less than 6. 5 plus 1 is 6, equal to 6. When a is 4, I can come up with 0, 1 and 2. Similarly for 3, 0, 1, 2, 3. For 2, 0, 1, 2, 3 or 4. For 1, 0, 1, 2, 3, 4 or 5. And for 0, I can have 0, 1, 2, 3, 4, 5 or 6, right? And if I have A 6 and B 0, I can also have A 0 and B is 6. So that's taken care of. Now the only additional thing we need to remember is I'm adding the modulus values of A and B. So if 6, 0 is a set, minus 6 and 0 is also a possible set. So for every non-zero positive integer, the negative equivalent also exists. So when I say 6, 0 is a set, minus 6, 0 is also a set. So in this case, I have got two possible sets. Now, let's forget the 0 portion, right? Or rather, let's do the 0 portion first. So for every possible integer with 0, it can have 5, 0 or minus 5 and 0. So for the zeros, I will have how many possibilities? Along with 0, I can have two set of numbers in each case. So those sets already exist. Now forget the zeros and let's focus on the non-zero numbers. So I have got a number 5 and a number 2. So plus or minus 5, plus or minus 1. So two possible values, 2 2's are 4 possible values. So there are 4 combinations possible here. 4 and 1, 2. So 1 number and 2 numbers. So 2 possible plus minus and 4 possible plus 1 minus 1 plus 2 minus 2. So 2 into 4 gives me 8 additional pairs. So let's work it out step by step. 2 and 6. So additional of 12 pairs. 2 and 8. 16 pairs. Then I can have 2 and 10. So that is additional 20 pairs. But with 0, this is a single number, right? 0 cannot be plus or minus. So single number with 6 possible numbers. So that gives me total 6 pairs. 1, 2, 3, 4, 5, 6. Okay, no, this is 1, 2, 3, 4, 5, 6, that is 12. So 1 into 12. So this is additionally 12 possible numbers. Okay, am I missing out anything? No. So plus 5, 0, minus 5, 0, plus 5, 1, minus 5 and 1, right? And minus 5, minus 1, plus 5, minus 1. Okay, so now this is 2 plus 6 plus 10 plus 14 plus 18 plus 22 plus 14 again. So I get 2, 6, 10, 14, 18, 22 and 14 pairs. No, let us see whether we actually have 14 pairs here. No, 0 and 0. Okay, so this is only 1, right? That's the one error here. 0 and 0 together, no plus minuses, so only one number here. So again, this is 13. So now let's add up. So 2 plus 6, 8 plus 4, 12 plus 8, 20 plus 2, 22 plus 3, 25, 2 carry, 3, 4, 5, 6, 7 and 8. So I have a total of 85 combination of numbers possible, right? And I don't have to worry about the x minus 5 part, because if xa is 6, then the corresponding value of x is 11. For a is 5, the corresponding value of x is 10. So 11, 10, 9, 8, 7, 6, 5. These numbers are immaterial. I just need how many distinct numbers are possible. What are those numbers? Doesn't matter much. So I have a total of 85 different such numbers which are going to satisfy the given inequality. Now, of course, I made an error here, assuming this to give me two values, forgetting that 0 is plus minus. So working this out is a bit dangerous, because you might forget considering the negatives, forget that 0 does not have a positive or a negative sign and so on. So let's take a look at another approach to this particular problem and see whether we are able to get the same answer. Remember, as of now, I've got 85 as the answer. Does another approach give me the same result? Okay, so I'm going to start the same, where I say mod x minus 5 plus mod y minus 5 is less than or equal to 6. I'm assuming x minus 5 is a, y minus 5 is b. So mod a plus mod b is less than or equal to 6. So I know that the extreme values are 0, 6, right? Or 0 and minus 6, or 6 comma 0, or minus 6 comma 0. These are the four extreme values of the numbers. Okay, let's see where we can plot this on a graph. So I'm going to take a smaller and different color pen to plot my graph. Okay, so this point is 0 comma 0, the center. So I have 1, 2, 3, 4, 5 and 6. Similarly 1, 2, 3, 4, 5 and 6. Similarly 1, 2, 3, 4, 5 and 6. 1, 2, 3, 4, 5 and 6. This is my graph with this as my central point. Okay. Now what can we do? We first plot the points. So 0 comma 6 is this, 0 comma minus 6 is here, 6 comma, okay, this is, sorry, 6 comma 0 and minus 6 comma 0. 0 comma 6 will be this point, and 0 comma minus 6 will be this point, right? And because the power is 1, they represent straight lines. So let's just draw the lines connecting these points. If I join it correctly, it should go somewhere like this, right? It should pass through each of these points, right? So this one should actually pass through this, this and this, something like this. Okay, not a straight line, but it's fair enough for our purposes. Okay. Now, all I have to do is find out how many intersecting points are there, because all these intersecting points are exactly the points which will give you the sum less than or equal to 6. So any point on the line is going to be 6, and any point within the line is going to be less than 6, right? So let's count how many such points exist. We are not going to take into consideration the lines first. So within, how many points are there? Let's see. So 1, 2, 3, 4. But if I sit and calculate everything, it's going to take me too much time. But symmetry works. If I'm able to calculate the inner points in one area, this is 4 times that. So let me ignore the axis and the outline. Let's first count in one quadrant how many points are there. So let's count 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. So points within is 4 times 10, which is equal to 40 such points. Okay. On the axes, how many points are get including the edges? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 and 13, 14, 15, 16, 17, 18, 19. Already counted. 20, 21, 22, 23, 24 and 25. So I get 25 points on the axis and then just the borders. If I calculate for 1 multiplied by times is for everything. So 1, 2, 3, 4 and 5. So 4 times 5 is 20. Those are all the points. 40 plus 25, 65 plus 20, I get a total of 85. Yep. So even making a graph like this can actually help you solve that. But you have to be careful in drawing it, making sure that you correctly calculate points on the axis, on the borders and everything inside the graph that we got. But either way, you get the same answer. So 85, pretty confident, should be the right answer to this question.